Most people are familiar with the cable that supports our networks and our telephone and other ICT devices inside of the building. But there's a whole nother type of cable called outside plant cable that provides support for those cables, and that is the topic of today's show.
Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling Podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you gotta ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? In this podcast, you'll learn the differences between a 66 and 110 punch tool, the proper way to install a support cable, along with testing and certifying the cable. What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. So join us as we talk about the ever-changing world of telecommunications. From ISP to OSP, from copper to fiber, design to installation. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Welcome to the show where we tackle the tough questions that are submitted by installers, project managers, estimators, IT personnel, and customers. On this show, we connect at the human level so that we can connect the world. If you're watching this vlog on YouTube, would you mind hitting the subscribe button and the bell button to be notified when new content is being created? If you're watching this on or listening to this on iTunes or Google or some other podcast platform, would you mind leaving us a 5-star rating? If it's not 5 stars, let me know what I can do to make this a 5-star show. Those couple little steps helps us get this content out to more people so we can educate, encourage, and enrich the lives of more people in the ICT industry. Also, don't forget our After Hours broadcast series, broadcast Thursday nights, 6 p.m. Eastern Standard Time, where you can submit your questions to be answered live by your favorite RCDD. Well, that would be me. And on LinkedIn, YouTube, and Facebook. And if you missed the live broadcast, don't worry, they are recorded for later consumption. Make sure you send your questions early to questions@letstalkcabling.com. Also, make sure to check out our webpage, and that's where you can find all of our recorded podcasts, recorded vlogs, and articles. You can also find methods there to help support this channel either through Patreon, Amazon links, or one-time donations. So outside plant cable can be divided into two major categories: cable owned by the access provider or service provider, and cable that's owned by the customer outside plant. On this show, we're going to focus on the customer-owned outside plant. Outside plant cable is a cable that's owned by the customer and connects their buildings together. They paid a contractor to install that cable and are responsible for any repairs needed for that cable, any additional cabling that might be needed for growth. It is their responsibility to take care of that cable. Unlike the access provider backbone cable, just for contrast, if the outside plant cable is providing access to the public switched network, then the access provider is responsible for keeping that cable up and running all the way to the demarcation point found inside of the building. The telephone cable also has to comply with regulations that are set forth by the local government and also the federal government. When the customer decides to install a copper or a fiber backbone cable to connect all their buildings together, there are 3 considerations that must be evaluated before they determine which type of cable, aerial, underground, or direct buried cable, to use. The first consideration is how much connectivity will they need, plus how much will be needed in the future. Planning for growth in advance, while may cost more money today, it will save the customer more money, probably about tenfold, over the lifespan of their cable plant. The customer will also look at the existing equipment they are currently running and determine the bandwidth requirements for that equipment and which type of media will be best suited for that cable. Sometimes copper is not the best choice. Sometimes multi-mode fiber is not the best choice. How much do you need? How much do you need for planning for expansion, for future expansion? This is why you should bring in a professional who understands your needs and can help you plan for this costly endeavor. One of the best suited professionals suited for this task is an RCDD. Based on those needs, an RCDD can determine what can be made, what types of cable, what types, and what's the best for the applications that the customer is currently running. A customer who may also need to be adding to a campus environment for just a telephone network and a computer network may be best served by a copper backbone and a small count fiber backbone. While another type of customer that has a larger network, for example, a data center with supporting buildings, may require ribbon fiber, which counts into several thousand strands of fiber. And finally, the routes are going to play a large part in that decision process. The location of the parking lots, the trees, the shrubs, as well as local code or corporate restrictions will also dictate if the cable should be routed either aerial, underground, or direct buried. Other considerations include right-of-way easement and permits, and locating other buried cables. I'll cover those in another show. So let's look at those three types of cable in no particular order: aerial, underground, and direct buried. First, let's cover aerial cabling. Aerial cabling is a cable that exits a building and hangs in the air hung on telephone poles. Some smaller installations may have where it just comes out of the building and goes directly to another building and may not have any poles in between them whatsoever. But basically, you can see the cable hanging in the air. The advantages of installing aerial cabling are first that this type of cabling can be installed relatively quickly. Also, this type of cable is going to be in plain sight, so it can be visually inspected and maintained pretty easily as well. The disadvantage list, however, is a lot longer. One thing a customer will try to do by saving money is to use existing telephone pole infrastructure. The cost of making those poles ready and compliant with the owner of those poles will be not only time-consuming, but also costly. While there are times when this option is going to be the wise choice, placing new infrastructure will probably be the better route to take anyway. Aerial cabling is very susceptible to the environment in which it's going to reside. For my friends up north, you're going to have to worry about ice loading. This is when it rains and then the rain freezes on the cable hanging in the air, and that adds weight to that support structure. Water's about 8 pounds a gallon. Another consideration is wind loading. This is how much force the wind places against the hanging cable. If you've ever driven a car or a service truck and have a tractor trailer pass you on the highway and you felt that air being pushed by the tractor trailer against your vehicle, pushing your vehicle almost out of its lane, you quickly understand why this force must be considered. And since we live here in Central Florida, we also have to consider wind loading from hurricanes and tornadoes caused by those hurricanes. Wind loading may also cause branches or maybe even trees to fall on the aerial cable plant, causing it to break, be broken, and have to be fixed. Both wind and ice loading may also cause damage to the building. As the extra stress is applied to the aerial cable, it could pull the cable out of the anchor points out of the building, and depending how it's anchored, could cause a considerable amount of danger and damage to the building. The next consideration is to factor in the vehicle and pedestrian traffic. The bigger risk of the two is going to be vehicular traffic, but never forget the clearances you're going to need for pedestrian access. There are simply just not enough clearance for delivery trucks and tractor trailers to bring those deliveries to the buildings. I have real life experience here when one of my father's dump trucks ripped down some aerial cabling because the bed of the dump truck was not completely lowered. It caused a lot of damage to the outside plant cable, and that was a huge insurance claim. But let's be honest, aerial cabling hung all over the campus may not be very aesthetically pleasing to the customer. Most customers who value aesthetics over price will likely stay away from this type of option. Aerial cabling may not be allowed also by your local jurisdiction because of the frequency of storms or hurricanes. The next option is to put the cable directly in the ground. There are two main ways that this can be done, either direct buried or underground facilities. While they are similar in the fact that they are both in the ground, there are distinct differences between these two options. The first option is direct buried. In this scenario, you're going to dig a trench below the subsurface and then place the cable in that trench, which can be done either through trenching, plowing, or even directional boring. In campus environments, it has been my experience that trenching is probably the most common method chosen. Directional boring is typically going to be chosen when the cable's got to make extremely long runs or if it's got to cross right-of-ways, waterways, or other types of scenarios where trenching or plowing is just simply not a good choice. Think of your long-haul distance carriers for directional boring, and that equipment is extremely expensive. So when trenching, you could either use extremely expensive equipment or sometimes even a shovel, depending on the length and the composition of the ground that you're trying to dig this trench. The cable is going to be placed directly in that trench and then placing material back on top of the trench to cover the cable. When trenching, there are some additional safety considerations that the installer must consider. If the trench is required to be more than 5 feet when it's being dug, then cave-in is a real danger to the people working inside that trench. The sides of the trench should be shored, sloped, or maybe even stepped. The material that you've dug out of the trench should be placed a minimum of 2 feet away from the edge of the trench so none of it can spill back into the trench. Also, an emergency plan should also be documented on how to respond to any event, including responsibilities of each crew member, the location of the nearest fire department, nearest hospital, and who would direct in the first responders during an event to make sure that everything's going to go safely. And those are just a few things that the safety plan should cover. The advantages of direct burial application is the cable is out of sight. It's a more aesthetically pleasing look than aerial cabling. It is easier to make changes in the route of the cable because of landscaping, sidewalks, and parking lots. Literally all they got to do is just turn the direction of the trencher. There is less planning required to make those changes of any direction, and direct buried projects usually have a pretty low initial cost for most installs, except for the cost of the actual equipment itself. But a trencher is a lot cheaper than a directional boring device. The biggest disadvantage for directional boring cabling is that growth can be quite difficult. When a customer decides that they need new facilities, then you have to dig a new trench. And hopefully the old cable placement was documented pretty well, and the customer still has that documentation. I've spent many an afternoon on emergency repairs when somebody should have documented where the direct buried cable was, and it wasn't, and that cable was hit and dug up and damaged. It usually happens on a Friday afternoon, and usually happens when it's either raining or snowing. The other disadvantage is that while the cable may have some type of rodent shield within the cable, that in its design help discourage the damage, it also happens that there's no protection for the actual cable from the weight of the ground that's going to be placed on top of it. In some scenarios, that weight can be quite significant. The other below subsurface installation method is called underground cabling. In this type of installation, a trench is also dug, and then either a conduit or a duct bank system is placed inside that trench. Now, the number and the size of conduits or ductwork system will be basically determined on the number and size and types of cable, plus for future expansion. A minimum of 4 4-inch trade conduits should be placed in that trench, and 1 additional 4-inch conduit for each telecommunications service entrance point. It is better to have it and not need it than need it and not have it. Now, some of those cables you might be consider using Maxell or some type of polyethylene interduct tube for fiber. This will help the customer get the most money out of each one of those conduits that they just paid a whole bunch of money to have installed in the ground. Depending on the length of the system, then you might have to install maintenance holes or hand holes in order to facilitate installation and routing or changes of the cables in change of ownership. This type of installation also provides for out-of-sight, clean aesthetic looks and additional protection from the cable being inside the conduit or the duct bank system. Now, the best advantage the underground has compared to its brother, the direct buried cable, and its other brother, the aerial cabling applications, is its ability to accommodate growth in the cable plant. The conduit and the duct bank system, as I mentioned earlier, should be designed with future expansion, and if they've been designed as this laid out by the TDMM, it will have future already figured out in that expansion. Then it's just a matter of attaching your new cable to the pull rope left by the installation crew. Pro tip, always leave a pull string. If there is no pull rope, all you got to do is replace the old cable, is pull the old cable out, attach the pull rope to it, and then pull the back out. Now you got a pull rope in that conduit system. Attach a new cable to the pull rope and pull the new cable in. While typically underground is going to be the most expensive way to install a cable in the building or between buildings, initially, its ability to place additional facility elements without having to dig more earth becomes the cheapest when factored across the lifespan of the building. Because again, you're just pulling the cable in that pre-existing conduit. You're not having to get the trencher back out there to dig more holes. But there are some disadvantages to underground cabling. The initial cost of construction can be quite expensive when you're factoring in trenching and the conduit. There are disadvantages to underground cabling. The cost of the initial construction, especially when designed correctly, could be quite high for some customers. And this is going to place a burden on you to instruct them that the overall cost of the underground cabling over the lifespan of the building, it will actually become the cheapest. And furthermore, the planning for the underground will require you more effort. You have to account for the sizing and the bend radiuses for all those turns that you got to make with those direction changes with the conduit. And you've got to make those changes well in advance. The best way to make changes with conduits is with sweeping bends, not 90-degree turns. When working with existing underground facilities, you will encounter water, dangerous gases, and maybe sometimes even rodents if that conduit has not been properly sealed. You'll also have to have a safety plan for trenching, just like you did for the direct buried, but with underground, you're also going to need a confined space training to include identification, monitoring, and working below grade. I have a show coming up in the future dedicated to working in confined space training. So in this show, we covered aerial cabling, direct buried cabling, and underground cabling, as well as their advantages and disadvantages of both. In future show topics, we'll definitely include confined space and also right-of-way permits. So until next time, everybody, be safe.